Good morning, everyone. My name is Xiang, and my teammate is Ching. We are excited to share about our assignment, AACS 2034 Fundamental of Network. Then we look about the table of content. In the table of content, we will talk about the network scenario, network design, calculation, subnetting IP, addressing table, and digital resource. Then we start with the network scenario. We need to help teach solution SDN PhD to design their network and set up local area network for the organization with buildings in different locations. They have the three locations, which is the location A, location C, location D. Between the location A and location C, they have 200 meters. Between the location A and location B, they have 500 meters. So in the location A, they have a different department at a different floor. At the second floor is a administrative department. First floor is sales department, and ground floor is customer service. In the location B, also same, they have three different departments, which is the gaming teach, big data hub, and cybersecurity. These departments have called the digital IT division. In the location C, they have 5 research and development lab. So that is our network design. This is a location A, location B, location C. In every location, they have a PC, switch, and router. So the PC is a connect to switch. We use the couple straight through cable to connect, and the switch to router also same, but router to router we use the fiber because the destination is too far, so we need the fiber to ensure their information can transfer to the location B. And especially is the location C. They have not the router, but they have the main switch to connect to location A router. This is our calculation and the host required. In the location A, admin creative department, they need 150 hosts to require, and sales department is the 200, and customer service is 400. In the location B, digital IT division, gaming teach need 250 hosts to use, and big data hub 100, and cybersecurity 50. And location C is a research and development lab, 150 hosts they need use. So we can use the host required to do the calculation. We can take one example for the customer service. Customer service is a 400 host required, so we can use the 400 plus 55% and time 400 equal result is a 620 hosts, and total hosts we can use power of X to get the result. So this is our calculation to calculation the host need. What is the 55%? 55% is the required of the growth percentage. So we use the 55% to do the calculation to get the result. And next we will talk about the subnetting IP. I will pass to my teammate Ching. Thank you.
Hi everyone, my name is Ching and my teammate is Xiang. So I will continue based on him. So here we are on the subnetting IP. So as you can see, here we have 8 subnets. And all of this is a classful IP address. So as you can see, the disadvantage of using a classful address is wastage of IP. So and the size of the subnet is based on the biggest one. So as you can see, the first one. So I already arranged from biggest to the smallest. So the biggest is the customer service. It requires 620 hosts. So the minimum can hold is 1024, which is 2 power of 10. And then 2 power of 10 is 1024 is 256 times 4. So as you can see, this one is the network address, which is 10.0.0.0, and the first usable address is 10.0.0.1. Then last usable address is 10.0.3.254, and then 10.0.3.255 is the broadcast address. Then same goes to all of the subnet. As you can see, start from 4.0, 4.1, then it ended and started from 8. So all the size is same. The reason I say is the wastage of IP, because you can see here, we also create a subnet purposely for the router 1 to router 2. So as you can see, the host required is only 2, but the size of the subnet is also the same, which is the front following the customer service one. So next up is the addressing table. So we have given each department a switch, and then the switch is connected to a router. So all the switch is using an interface of VLAN 1, and all the switch is given the IP of the default gateway +1. So the first one we have given the IP to the default gateway. The second IP we given to the switch. Okay, as you can see, 2, 2, 2, 2, 2. And the subnet mask is also, because it's a classful, so it's also the same for all the subnet. So this is our digital resource. So we use to complete our assignment. We have YouTube. We learn from YouTube to watch all the videos to help us in the assignment. And we use Zoom to record our video, Google Meet to have a meeting session. Then of course the Cisco Packet Tracer to have the details on how to complete our assignment, and also Draw IO, where we draw our physical layer. So now I'm gonna demonstrate how we complete this assignment. So this is our design. As you can see, we have location A, location B, and location C. Location A and location C is the distance is 200 meters, and the distance between location B and location A is 500 meters. Because copper straight through cable only can withstand 100 meters, so anything beyond that we use fiber cable. As you can see, this is red one. This red cable is the fiber cable. So first of all, I will show you how to assign a PC the IP address, IP4 address, and the default gateway. So as you can see, all this I already labeled, which comes from the this one we already assigned for each PC. So you click on this PC, and it goes to desktop IP configuration. So here you add in the IPv4 address, and then the custom subnet mask, and then the default gateway. The default gateway is this one, because the PC is on here. So the switch IP address is this one. Then the default gateway is this one. So as you can see here, okay. So now I will show you on how to create the VLAN 1 to give an IP address to VLAN 1. So you click on a switch. So CLA33. Password is AACS2034. Then configuration terminal. So here we use interface VLAN 1. Then IP address is already created. I will demonstrate again. 10.0.8.2. Then the custom subnet mask is 0255, 255, 252, and 0. And no shutdown. Then the IP of the default gateway is 10.0.8.1. Exit. Then make sure you complete unstart to save the memory so you don't lose your configuration. Okay. So now I will show you how to with the configuration that we have done in the switch and also the router, which is the same. So you go to CLI. So as you can see, I already created, but anyway, I will show you again. Okay, so you go to config key. Then first of all, you have to change the host name to switch AD, which I already done, but I will demonstrate to you AD, because I use AD because this is a administrative department, so switch AD, so it's a shortcut, easy to remember. So the next one is line console 1. Line console 0, then password JCLA33, and login. So enable. We create banners to show to the user. A banner which is all users only. So we exit. So we copy run start to save all the configuration in the memory to make sure we don't lose our configuration when we close the application. So I'll demonstrate to you. Exit. So as you can see, this one is the banner I created just now. Then the password is CLA33. When I enter enable, the password is based on the secret because the secret overrides the enable password. So it's AACS2034. So I successfully log in. So same goes for the router. I will just demonstrate for you for one router. So you go to CLI. I also created already, but I will show again. CLI33. Sorry. CLI33. So enable. We'll go to config key. Also change the host name to, let's say, router 1. And continue on the password and configuration. CLI33. Enable secret. AACS2034. Service. The service password encryption is to encrypt the password that I have created, so anyone else cannot see the password. So let me demonstrate to you. Wait for it to create a banner, please. User founding. Sorry, typo. It's only so exit, copy run start. So should show run. As you can see, the host name is router 1, and then the secret that you see is already encrypted, and the password also encrypted. As you can see, the password also has been encrypted. That's why I created the service password encryption. So that's it for the router, and then now I will start to demonstrate how to ping. So let's say I choose this PC AD1. I want to ping to GM3, which has a IP address of 10.0.5.4.5. So let's go ahead. AD1, go to desktop, then you go to command prompt. So we ping 10.0.4.5 to this is 2345. So let's ping this. Okay. Yeah. So as you can see, is show first two times it request it will show request timeout, because the result of this is because the IP is not registered in the ARP table, so it will show request timeout. Then after the second time, the ping already successful. Let me show you again. So I just ping again to demonstrate to you. As you can see, it will not show the request timeouts. It will directly successful because the address is already registered in the ARP table, so you no need to search. It will directly find the device. Okay, let's choose another one. So let's say RD3. This one has a IP address of 10.0.16.10. So let's go ahead. 16. As you can see, the address also not found in the ARP table, so it needs some time to search for it. So as you can see, the first time it says request timeout because it's not registered in the ARP table. Then and then after that it shows successful. So then I will show you on how to create static routes to communicate between router and router. So you go to router, go to config, then you go to routing here under the static here. As you can see, I already created. This one is, as you can see, the network is the network is the default gateway of the other side of the location. As you can see, I click router 1, so the network is default gateway on this one, or not default gateway, sorry. Is the network address of this department here. So as you can see, 10.0.4.0 is for this one, is for gaming tech, the network address. So as you can see here, gaming tech, this one, network address. So then the next hop is this one, the router, the next router, and also same 20 is from here, the network address, and then next hop is here. Same goes to the other router, also the same under static. As you can see, network is the network address of this one, this apartment, this department. So you can see 10.0.12, then 0. Then the next hop is the router from here, as you can see, 10.0.28.1. So that's it for my presentation. So go back here. So that is all from our presentation. Thank you very much.